Welcome to another video. This is the fourth video on the playlist of differentiation, and we are going now to find the derivative of f of x, where f of x is equal to the natural logarithm of x, which is also known as ln of x. And to find this derivative, we are going to use simply the first principle. Can you pause the video and try it? Then you pause and see the solution. That is the best way to learn. So let us begin it. So you know that we have to find f prime of x using the first principle. It is equal to the limit as h goes to 0 of f of x plus h minus f of x. This was derived in the last video, so you can go ahead and check in video 1, like all on h as h goes to 0. This is 0 here. Okay, so we are now having the limit as h goes to 0 of ln of x plus h. This we are increasing minus ln of x. Since our f of x is ln of x, this is it here. And after that, we are just going now to open this. This one now will be simply limit as h goes to 0. Limit as h goes to 0. I will combine these two logarithms. You know that log a minus log b, or natural logarithm of a minus natural logarithm of b, is equal to the natural logarithm of a. This is b here, of a on b. Okay, so if you apply it here, you'll be just getting your a simply x plus h, all that on x, all that dividing by h, the h down here, don't forget it. And I can write this neatly to be the limit as h goes to 0 of natural logarithm of x plus h on x multiplied by 1 on h, by simply putting this h to the other side. Okay, and now I'm putting 1 on h since the h was on the bottom. Okay, now we can go ahead and separate this one inside the fraction. The limit as h goes to 0 natural log of x on x plus h on x multiplied by 1 over h, and this gives us limit as x goes to 0 of limit as h, limit as h goes to 0, the natural logarithm x on x is 1 plus h on x multiplied by 1 over h. So in this way, I will make a line substitution that let h on x equals v, and from here we see that as h goes to 0, we'll be having v will be equal to 0 on x v. So this implies as h goes to 0, comma v also goes to 0. Okay, and from here we can cross multiply to have h equals to vx. If I cross multiply up there, so we're having h equals to vx and h of x equals to v. So we can now go ahead and replace this and this here. So now we're getting the limit as v goes to 0, since we are now substituting everything in terms of b, 1 plus v multiplied by 1 on vx. That is our h. And if you do that, you simply get limit as v goes to 0. I can bring this in front here, that is 1 on vx, natural log of 1 plus multiply by that, and I can still write it as limit as v goes to 0, 1 on v, let me write 1 on x multiplied by 1 on v, ln of 1 plus v, and this is neatly indeed equals to limit as v goes to 0, 1 on x multiplied by natural logarithm of 1 plus v raised to the 1 on v. I've just taken this power and sent it up there. We record that a ln b is equal to ln b raised to the power a. This a here. So this is our a here. Our a is simply 1 on v, and our b is simply this, what is in this bracket. Okay, so that is just what I've done. And you know that in limit, we can now go ahead and apply. This is a constant, 1 over x, it is independent of v, so we can write 1 over x limit as v goes to 0 natural logarithm of 1 plus v raised to the 1 on v. And by limit theorems, the limit as v goes to 0 of natural logarithm of 1 plus v to the 1 over v is equal to 1. And in this case, we now just get 1 over x multiplied by 1, and this gives us 1 over x. So we have shown that the first derivative, we have shown that f prime of x is equals to 1 over x. That is, if f of x equals to ln x, then f prime of x is equals to 1 over x. Okay, from here I'd like us to come to a nice conclusion that what you notice here is that let us move find the derivative of x. The derivative of x is simply equal to, we can take this to the power 1. This is the derivative of x, so it will be 1 comes down to the power x into 1 minus 1, which will be 1 x to the 0, which will be x to the 0 is 1. So this is the 1 up here, and what is remaining here in x. So each time you have to find the derivative of f of x. If f of x is equal to ln u can be anything, then f prime of x will be equal to u prime all on u. That is, here we just got ln x, and our x prime, the derivative of x is simply 1 dividing by x. That is what we got, 1 over x. So in our future videos, what if you find me to do the ln 2x plus 5? Okay, this one now will be what, the derivative of the inside, so it will be 2x plus 5, all that, all of this, the derivative of all of this will be equals to this prime on 2x plus 5. That is this is my u, and I find my u prime and I divide by u, and indeed this, the derivative of 2x is simply 2, and the derivative of 5 is a constant. Remember, this is 0, so we get 2 on 2x plus 5. So this is how we find the derivatives of a logarithmic functions, natural logarithm functions. Each time you find a function ln of u, then the derivative of that will be u prime on u, the derivative of that with respect to x. Thanks very much for watching and liking this video. Hope you have subscribed to the YouTube channel. I would like to see you in the next video. Share to your friends, and anything you have worry concerning math, physics, chemistry, in fact all the subjects, feel free to contact us, especially on our WhatsApp channel or on our WhatsApp numbers that you see on the intro of this video. Thanks very much.